I'm sorry. Yeah, I was going the backwards way there. Well, I had a backwards clock, one of those Mickey Mouse ones. It says an arc length with a central angle theta, central measure theta radians has a length of L equals R theta. This is just a formula. If you have a central angle and you have a radius, you can just plug it into this. So that problem we just worked, we could plug it in here. Well, could we? Because here it says arc length equals R, which is the radius. We got a radius, times theta. Theta is an angle. We had a fraction. We had 50 seconds. So you would actually had to find that angle and then plug it in, so we worked it the easier way. Let's work the other one. And I hate when they use L in formulas because it looks like a 1, so I'm going to put a big L there. That's arc length equals the radius times your angle. Formula, if you want to use it, memorize it. It says find the central angle measure of an arc length 9 centimeters on a circle that has a radius of 4 centimeters. So you have a circle with a radius of 4 and an arc length, and I don't know, I'm probably not drawing this to scale. An arc length of 9 centimeters, and we want to know pretty much what angles formed. That makes sense? An arc length of 9 centimeters, a radius of 4 centimeters. We want to know what angle did it go around. Easy, very easy. Arc length was what? 9. The radius was what? 4. So 9 equals 4 theta. Divide by 4, so theta equals 9 fourths. And again, anytime you use this formula, it's always in radians. 9 fourths, that's 2.25, right? I don't like radians. What if I wanted to change it to degrees? What do you multiply by? 180 over pi. So if you wanted that in degrees, but let's think about it. What was 180 degrees? 180 degrees was how many radians? Pi, right? 3.14. Did this go a full 180 degrees? No. So is my picture drawn to scale? No, because it looks like it went over 180. Makes sense. So therefore it traveled 2.25 radians. Very easy formula to use, so if you do need that, that's how you do it. Last thing we're going to talk about is angular speed and linear speed. If you're spinning on a Ferris wheel, there's two different types of speeds taking place. If you're spinning on a Ferris wheel, you have a linear speed and you have an angular speed. And this is only when you're spinning in a circle. And you got all this centripetal force happening and all this. This is where you get into a little bit more physics. Let's talk about the difference between linear speed and angular speed. Linear speed, and you can tell a little bit more about it by the formulas. Linear speed is the arc length, the distance that you travel over time around that circle. Okay, so if you travel all the way around the circle, how do you find the distance that you travel? Circumference. Right? The distance around that circle. If you go from here all the way around, then that's the circumference of the circle. That's how far you've traveled. Angular speed doesn't measure how far or how fast. Angular speed is measuring how fast the angle's changing over time. And this is the best way I can explain it. Let's say that you've got two different people on some ride at the fair. One person's on the outside, one person's on the inside. Is one of them spinning faster than the other one? Angular speed, they have the same angle speed. Because let's say that this ride takes 1 minute to go all the way around. Okay, 1 minute. How many times did this person go around? Once. How many times did this person go around? Once. Right? But look at those two circles I just drew. Did one of them go farther than the other one? Yes. So did one of them. You're exactly right. One of them is going to feel like it's spinning faster than the other one. You know which one? You would think. But the one on the outside actually travels farther. Makes sense? In the same amount of time. If I travel 1 mile in 5 minutes, okay, and you travel 10 miles in 5 minutes, you're going faster, obviously. So that makes sense. So the one on the outside is obviously traveling faster, has a faster, and you've got to be careful here, has a faster linear speed. They have the same angular speed because in that 1 minute, both of them traveled 360 degrees. Right? They spun one time. But linear speed, they went further. The one on the outside went further. So there's the difference between linear speed and angular speed. Let's work some problems. Yeah. No, get on the outside so you'll spin faster. So you'll go farther. Linear speed. Here's your formulas, and these are easy formulas to remember. Linear speed and angular speed. The way that I remember it, linear speed is measured in like miles per hour. So it's the distance. Think about miles per hour. What's the hour? Time. So it's the distance you travel over the time. Angular speed is measured in like degrees per minute or radians per minute because you're spinning. It's a change in angles. So can you tell me what the formula for angular speed would be? The angle change, I guess you could say, over time. So it's how much the angle changes over that amount of time. And there you go. Linear speed, arc length over time. Angular speed is angle over time. Example 6. A circular gear rotates at a rate of 200 revolutions per minute. Let's talk about RPMs. RPMs would be... Would an RPM talk about angular speed or linear speed? Do you know that? Like an RPM of your truck or car, it's spinning, right? Revolutions per minute. That's the angle. A revolution would be 360 degrees. If it's traveling at 1 RPM, that's 360 degrees per minute. That's an angular speed. Okay, an RPM would be. But anyway, it says a circular gear rotates at a rate of 200 RPMs. So each minute it spins 200 times. Revolutions, 1 revolution to spin per minute. So 200 spins per minute. What is the angular speed of the gear in radians per minute? Okay. If it travels at 200 RPMs, we want to know how many radians it travels. And don't make these harder than what they are. Let's use the common sense approach. Let's forget about formulas and all this. 200 RPM. Yeah. Think about this. It spins 200 times each minute. Each spin, each time it goes around, how many degrees is that? 360 degrees or 2 pi. I want to leave it in pi's because they said measure it in radians per minute. So if it spins 200 times, each of those times is 2 pi. So what's going to be your 400 pi radians per minute? Any questions about that? One revolution, that's it on that one. 1 revolution is 2 pi, right? But how many times does it spin in that 1 minute? 200 times. So just do 200 of those. 200 revolutions. A revolution here is a 2 pi. So 200 times 2 pi would be 400 pi radians per minute. That's to me, I like degrees better. That's 72,000 degrees each minute is how many degrees that thing's spinning. So that's the easy way of doing it. That was A part. It says B part. What is the linear speed of a point on the gear that is 2 inches from the center in inches per minute? So we're talking linear speed now. And I like to draw pictures. You have this gear that's traveling 200 RPMs. I'm not going to put the teeth on it. There's a point that is 2 inches from the radius of the gear. And that bug, imagine a bug being right there on that point. We want to know what is his linear speed. How fast is he spinning? Okay? So we're asked for a linear speed. And think about this. We've got this gear that's spinning. It's spinning 200 times each minute, but we're worried about distance. How far does it travel distance-wise over time? Because that's linear speed. With me? Let's discuss how far it did travel. Well, what if it just spun once? What did we call that a while ago? If this thing walks around or goes around or whatever one time, that is the circumference. With me? The distance around it once is the circumference. So let's find the circumference real quick. Pi d. Circumference is pi d. What is d? 4. What is pi? 3.14. 3.14 times 4 is 12.56. Let me caution you on this though, because you're fixing to have such big numbers. Instead of using 3.14, you might want to use the pi button. And I'm going to actually do that. I'm going to do 4 times pi, which is 12.566. And notice even 12.56 is wrong, because it would actually round up to 12.57. I use the pi button, which is right above the caret. 3.14 times 4, because you got to do times 4. So that's the distance it travels if it's spun one time. But we're wanting to know the distance traveled total. How many times did it spin in 1 minute? 200 RPMs. That means it went around 200 times in 1 minute. So to get the linear speed, well, if it had just spun once, it was 12.56. So all you got to do is times 200. 2,513, we'll just call it that. 2,513. Let's think about what our actual, I just went blank, units would be here. 2,513, what is the distance traveled or measured in? Go back to the problem, inches. So 2,513 inches per minute. Yep. That's how many inches this thing travels, because one rotation was 12.56. But it spun 200 times in 1 minute, so it traveled this far, which might not seem like a lot. But how would you change that to feet per minute? Yeah, just divide it by 12. There's 12 inches in each of these feet, so take your answer, divide it by 12. 209, was it 0.4? So this thing's traveling at 209 feet per minute. This is a gear that's rotating. Just one gear rotating. Each minute it travels 209 feet. This point right here, 209 feet. Any questions? Next problem.